next part of this chapter is to solve a cubic equation. So just in case you've already forgotten the difference between the expression and the equation, I'm going to repeat here. Right, so what is the difference between factorizing and solving an equation? Right, so factorizing a cubic polynomial means finding the factors of the polynomial. So the example given to you, it's on the screen. Solving a cubic equation means finding the values of x, okay, when fx equals to 0. So where do you get it from? You actually get it from factorization. So to solve a cubic equation, first of all, you have to do the factorization. Okay, then after the factorization, then you solve it by applying the zero product rule. So let's put what we have learned into practice. Let's look at example 3. Right, so solved the cubic equation. Right, so the keywords here is solved. Solved the cubic equation. So solving it means to find suitable values of x that satisfy the equation. And obviously this is an equation. Okay, I don't have to remind you. Okay, look at the equal sign there. All right. So before we can solve it, we need to apply the concepts of factorization. And to factorize your cubic polynomial, we need to find a factor, right? We need to find a factor using factor theorem. So to remember, we say that the shortcut is just to use the calculator to help us. Okay, so the calculator, depending on the type of calculator, the brand of the calculator, I'm using Casio, so it's mode 3, 4. Right, so to remember, that's one thing to take note is that if you're using a calculator, you have to arrange, okay, because sometimes the question does not arrange for you, you know, the power of the term from in descending order. So sometimes they will just try to try to make life a little bit difficult for you. So you have to ensure that you arrange it from the smallest power, from the biggest power to the smallest power. Okay, from the biggest power to the smallest. All right, okay, so from your calculator, what you will see are these. Okay, so you just choose one of them, and I'm going to choose this one. Okay, so this will give me x minus 6. So x minus 6 will be a factor. X minus 6 will be a factor. Right. So we need to factorize it first. So the presentation part is important. Right, we're going to let f of x equals to x minus 6 multiplied by your quotient. Okay, right. And as we have explained before, if this one is of degree 3, your factors is of degree 1, then your quotient will be of degree 2. So this will be x minus 6 multiplied by ax squared plus bx plus c. Okay, so I'm going to use compare coefficients of a similar terms. So this will give me x cubed. So divide by x cubed throughout will give me x cubed divided by x cubed will be 1. So a is 1. And then this one here multiply with this. Negative 6c equals to 12 here. So c will be negative 2. Right. So with all this, I'm going to put it back here. Okay. So again, I'm left with to find the values of b. So I'm going to compare coefficients of the x squared term. So I have to take x times bx, at my bx squared, negative 6 times, oh, okay, wait, too far away already. Negative 6 times this. Okay, so therefore bx squared minus 6x squared will be equals to this term here, and you divide by x squared throughout. B minus 6 will give you negative 7, b will be minus 1, negative 1. Okay, so right, so if you put everything back into your fx, you will get fx equals to x minus 6. Okay, not enough space. Wait, hang on, I think I have to write it here. Okay, let me try to write it smaller a bit. We'll get x squared minus x minus 2. Right, then we try to simplify again. Not simplify, sorry. Factorize this again. Give it x minus 2, x plus 1. Okay, so the next step is very, very important because you're solving a cubic equation. Right, so when f of x is equal to 0, you're solving it. So you will have x minus 6, x minus 2, x plus 1 equal to 0. So therefore, x minus 6 is equal to 0, or x minus 2 equal to 0, or x plus 1 equal to 0. And hence, your solutions are x equals to 6, or x equals to 2. These are your roots, or the solution of your cubic polynomial. What is zero product theorem? We have been applying a lot of zero product theorem a lot of times when we solve quadratic equations or even solve cubic equations. It's just that we're not too sure that what we are doing. It's called the zero product theorem. So basically, zero product theorem is that if you have a times b equals to 0, if your right hand side is equals to 0, right, and the left hand side you manage to factorize it into the linear factors, or then what they're saying is that from the example you're given, it's like x plus 1 is equals to 0. Why is it? Because if x plus 1 is 0, anything times 0 will give you 0. So if any one of them is 0, you'll be ensured that the right hand side you would end up to get a 0. Right, so it's x plus 1 equals to 0, or x minus 1 equals to 0, x minus 3 equals to 0. So from there you can find the values of x. Right, so the important thing to take note is that if you want to apply zero product theorem, the right hand side has to be equals to 0. Okay, the second concept that that we will be learning is how do we form polynomials using real roots. Now, so far what we have done is the examples we have done, like factorizing your cubic polynomials into linear factors, and then after that solving your cubic equations. We're actually finding the value of x. You're finding the roots of the equation, right? So but we also need to be able to form the polynomial. That means if I were to give you the roots of the cubic polynomials, are you able to form the polynomial? Right, so this is the so from the examples given there, right? So if you are given this polynomial fx, and if this polynomial fx have all these as the real roots, right? So how do you form the polynomial? So if you were to work backwards, remember the x equals to negative 2, x equals to 1, x equals to 3 is something like what you see on the calculator, or if you're given this a polynomial, and then you use a calculator to substitute in the coefficients of x cubed, x squared, x, and the constant, and then you end up getting x equals to x1 equals to a value, x2 another value, x3 another value. Okay, recall how do we actually form our linear factor, right? So if you're given x equals to negative 2, how do you form your linear factor? So from x equals to -2, the linear factor will be x plus 2, right? And then from x equals to 1, it will be x minus 1. And from x equals to 3, it will be x minus 3. Right, and if you multiply them all together, these are the three linear factors. Okay, so if you multiply them together, you would have this. Okay, so why is it that's a k here? Why is it that's a k here? Because for a cubic polynomial, you can write it as ax cubed. The format for a cubic polynomial is ax cubed plus bx squared plus cx plus d. And a being the coefficient of x cubed, it is not necessarily 1 all the time. It can be just a real number. So it can be 2, can be -4, can be 5, etc., etc. So therefore, we cannot assume that your cubic polynomial is in this form. If you write it in this form, it means that the coefficient of x cubed will be 1. And then it is not necessary. It is not necessary that what I mentioned earlier on, it can be any values. So therefore, you would multiply it with a constant k. Depending on the questions would tell you the coefficients of your x cubed.